Good morning. Today we will see about the various constants, the various data types, and the various control structures used in a Java programming language. Java constants are mainly classified into two. We call them numeric constants and character constants. In numeric constants, we have both the integers and the real constants. In character constants, we do have the single character constants and the string constant, which is a combination of many characters together. We even use variables in Java programming language to store the state of an object. Just like any other programming language, the syntax is we first write the data type, the variable name, and an initial value which is optional. For example, we can have things like int I or int I comma j. Or we could even have something like int count equal to 0, where count is given an initial value of 0. Now let us learn a very important concept in Java called Java data types. Java data types are classified mainly into two. We call them intrinsic data types or primitive data types. And the second classification is non-primitive or derived data types. In the primitive data types, we have the numeric, which would include integer, float, and double. Non-numeric, we will have character and Boolean. In the non-primitive or derived, we do have data types which are derived from the primitive. Example, classes, arrays, interfaces. We will see about each data type now in detail. As we earlier saw, primitive, we do have integer. We will first talk about primitive integer types. We have four types of integer data types in Java: byte, short, int, and long. The memory needed for each is different. Byte will need only one byte. Short would need 2 bytes. Int would need 4 bytes of memory, whereas long would require 8 bytes of memory. The range also is written in the third column. Byte would have a range between -128 to 127, and even the data types short, int, and long would have ranges as given over there. You could see that if it is a long data type of integer, it would be able to store a very huge number. Next, we will see about floating point data types. Floating point data types also fall under the primitive category. In floating point data types, we do have two types. We call them float and double. Float requires 4 bytes in the memory, whereas double requires double of float, which means double would require 8 bytes of memory. If we want to have a mathematical calculation with very high precision, we would go for double rather than float, because double will give you a higher precision of up to 15 digits, whereas float would give you a precision of 7 digits. For example, if you were to calculate the area of a rectangle, a square, or might be something else, you could go for float. But whereas we are going for calculation of angles or might be calculation of quadratic equations, it would be preferably in double, where the precision we need would be higher. We do even have a data type Boolean. Boolean is also a primitive data type. It represents only two states. It can either be true or it could be false. The syntax is Boolean. Boolean is a keyword, Boolean. And then we can have a variable name. I have written a variable name called result over here, equal to either true or false. Both true and false are keywords. Here in this example, result by default, I have assigned it as true. We even have character data types. It also falls under the primitive category, where we could have literals in single quotes. For example, the letter A. If I want to give a tab space of 4 spaces, I can give a \T, which would denote to be a tab. If I want to denote special characters like a single quote, I can use it using the escape character, which is shown below for single quotes and for double quotes. We do have many categories of operators in Java. Arithmetic operators, which include addition, subtraction, multiplication, division, and the modulo. Then you have relational operators, greater than, or equal to, etc. Then we have logical and, or, and not operators. We do have the increment and decrement operators. We do have the bitwise operators. We even have the shift operators. We have a conditional operator, assignment operators, casting operators, where you have the data type in simple brackets. It is similar to the typecasting in CPP. Then we have the method operator, which are simple brackets, and we even have instance of operator. As we all know, all the operators here are very familiar to us, which we have been using in the other programming languages, except instance of operator. Instance of operator is a new concept which we will be learning in Java. Let's have a quick go through the various arithmetic operators. OP1 plus OP2, you can add 2 operators, you can subtract 2 operators, you can multiply them, you can divide them, you can do a modulo to get the remainder. And then we have the increment operators and the decrement operators. As we already know, plus plus OP, the OP value is incremented by 1 and it is evaluated after it was incremented. And OP plus plus, it is incremented and evaluated before OP was incremented. Similarly, we have the decrement operators, minus minus OP and OP minus minus. These are similar to the increment decrement operators we used in C and CPP. We have relational operators to compare 2 values and get the relationships between them. The result of a relational operator will be either true or false. We will quickly go through the operators. You have the greater than operator, greater than or equal to, less than or equal to, equality operator to check whether OP1 equal to OP2. And then we have the not equal to operator. Kindly go through the difference between the assignment operator and the equality operator. Assignment operator will be a single equal to, while equality operator will be a double equal to. Then we have logical operators in Java. We have 6 logical operators, the double ampersand for logical and single ampersand for bitwise and, the double pipe for logical OR, and the simple pipe for bitwise OR. And we even have the exclusive OR and the logical NOT operation. Just like we have in CPP and C, we have the conditional operator or the ternary operator in Java 2. The structure would be expression 1, question mark, expression 2, colon expression 3. It means if expression 1 is true, do expression 2, or else do expression 3. Now, let us quickly go through the various control structures in Java. Control structures in Java are similar to the control structures we have learned earlier. The control structures in Java are divided into 3 categories: selection statements, iterative statements, and jump statements. Selection statements are categorized into 2: if statement and switch statement. If we have several kinds of if in Java, we have the simple if, we have the if else loop, we have the nested if loops, we even have the if else if. Switch statement, we have the switch case statement for selecting one out of many cases. For iterative, we have the while loop, do while loop, for loop. The fourth one, called for each, is a new addition in Java. You even call it advanced for loop. It is called for each loop or advanced for loop, which we will see in detail later. Jump statements are similar to the earlier jump statements. We have break, continue, and return. Thank you for the day. Kindly revise your control structures and data